Our improving forecast today. It's been a very slow process. It's been about 0.5% improvement every year in a 24-hour forecast. I fully expect that we're going to increase that, at least double that, at least 1% per year over the next 5 to 10 years. And unfortunately, though, our populations are growing faster than our ability to improve our forecast. Along our coastlines, our populations are growing faster, which means we have to provide longer lead time forecast, and that offsets what we're doing in terms of the improvement of the forecast.
Although the probability of a worst-case event in any one location in any one year is actually very small, it's almost inevitable one day someplace where a storm increases intensity unexpectedly, and we haven't evacuated a large enough area, or a storm changes track or increases its forward speed and we didn't begin to leave early enough. In that kind of scenario, you could have thousands of people die in any number of places around the coastline right now.
When to stay and when to leave is the critical choice in any storm. The Mississippi coast looks peaceful, but residents here have often faced that decision.
Hurricane Bob of 1985 was nothing more than a nuisance storm, except for the marine interest. Then in 1965, Hurricane Betsy gave us about a 10-foot tide. It was pretty serious. Our record storm up until 69 was the 1947 storm, about a 14.8-foot tide. And then finally, Hurricane Camille here at Gulfport Harbor was 20.1 feet above normal.
Soon after entering the Gulf of Mexico, Camille began to intensify. On August 17, 1969, at 10:30 in the morning, forecasters predicted that Hurricane Camille would hit Mississippi that evening. 200,000 people and only a few hours to flee.
At 4 o'clock that afternoon, I left the EOC for a few minutes to run down to past Christian Isles and make sure that that area had been cleared out. There were still 3 families down there, but they were packing up to leave. Coming back, I noticed some activity around the Richelieu apartments and pulled up and talked with what I think was the manager. She said, we're not going to leave. Those that have left have already gone. Some of us are going to stay here and have a hurricane party. I said, well, my goodness, lady, this is a very dangerous area. You need to get out of here. Please pack up and leave. We did not have the authority for forcible evacuation then. We do now. She said, don't worry about us. If the water comes up, we'll go up to the 3rd floor. I said, well, lady, what are you going to do if the bottom floor goes? The 3rd floor is going to come down with it. And that's exactly what happened.
Well, I got off from work early, came home, and everybody was talking about there was going to be a party. So I went and started talking people into staying, because I'm from Florida, Jacksonville, and we used to have these hurricane parties, and everybody would go to each other's house, drink and party and carry on, cook out. So I went by and picked up a lot of food, some booze, and I had some pills and stuff there. So I went and talked to everybody into staying. There was around 30 of us staying. And about 6 o'clock, everybody kept coming around and knocking on the doors, telling us to leave. And the manager and his wife said they had been in the a hurricane party. I think it was Betsy. And he'd just gotten as far as the 1st floor, about 8 feet high in the building. That building was one of the safest buildings because it was built real good. And we were going to have the party on the 3rd floor. I was on the 2nd floor.
The evacuation continued up to the last minute, but no one had predicted just how strong Camille would become. With winds gusting to 200 miles per hour, the sea began to swallow the Richelieu apartments.
Oh, I says, Fritz, I says, it's fixing to cave in any minute. I says, we've got to go. And so we ran back, and both of us stood with our backs to the door, and that water come through, it busted out the window and came through. And now we were on the 2nd floor, so you know how high it was. Then it came around to the back and busted in our bedroom window. And the bed started floating about halfway up, and he couldn't swim, so I blew up an air mattress like we had for the pool, and I told him to hang on to that. And I swam out, and well, right after I swam out, I got tangled up in the telephone lines, but the current was already off naturally by then. And then I heard him. It was so dark out there, and I heard him hollering, Marianne, Marianne, save me, and it had washed him out. And then, I didn't hear anymore, so I guess he had drowned it. And so all I could think about was like, on ships and everything, when they go down, so you see all the suction and everything. So I knew that building was fixing to go down because cracks had come all around the wall and everything. So I went and it got loose, and I started trying to swim, and I could see the lights up at where the hurricane party was, and the building just started all coming down in the water. And the river took me on, the water took me on, and they estimated it that the surge took me something like 12 miles altogether in and coming back out. I just kept praying the whole time for God to help me, and I kept saying that in the Psalms 23rd in the Bible. I kept, reciting that the whole time I was in the water and just praying for him to please give me another chance at life.
Mary Ann Gerlach was the lone survivor of the hurricane party. The other 23 who stayed behind, including her husband Fritz, were found over the next few days among the wreckage. The Richelieu apartments, which looked like this, were completely flattened by the storm surge. Hurricane Camille left a legacy of dislocation and death, 15,000 homes, and the entire economy of the area destroyed. But Camille did not stop there. It caused devastating flash floods as far away as Virginia. In all, Camille killed 256 people and left almost $4 billion in damage. 20 years later, few reminders are left. Here, a crumbling foundation overrun by weeds. The old Richelieu apartments, a monument to the cost of staying. The scars left by Hurricane Camille have been covered over by time and new construction. And for most of the year, the Gulf is peaceful. In tropical waters, seasons pass with little change, the weather moderated by the warm sea. But in summer, when the sun shines directly down, the ocean begins to store up an enormous amount of heat, creating conditions necessary for hurricanes. Some of this heat is released by thunderstorms, which erupt when seawater evaporates and warm air begins to rise, condensing and producing clouds and rain. But most tropical thunderstorms die off quickly. It takes a rare set of events to produce a storm as violent as the hurricane.
We know from forecasting experience that certain things have to be true of the atmosphere to have a hurricane. There must not be very much wind shear in the atmosphere, which is to say that the wind speed itself cannot change very rapidly with height. The reason for this is if you try to form a hurricane in such an atmosphere, the hurricane literally gets sheared apart before it can really get going. And so hurricanes don't like atmospheres with a lot of shear in them. The water has to be warm enough because the warmth of the ocean water is the source of energy for hurricanes. And apparently the warm water has to be sufficiently deep in the ocean. It has to be about 200 feet deep. If the warm water is too shallow, it's just in a thin layer at the top of the ocean, there's not enough energy there, and for various other reasons you can't get a hurricane. But even when all these so-called necessary conditions are met, you don't necessarily have a hurricane. You have to have something else come along to start it.
It takes what some scientists call a kick. In the Pacific, the trade winds collide near the equator, producing low-pressure zones and massive thunderstorms. In the Atlantic, similar disturbances occur over Africa. About 100 of these low-pressure waves move out over water each summer, but on average, only 6 become hurricanes. Air converging into the storm system begins to spin under the influence of the Earth's rotation. Hurricane forecasters look for this sustained circular pattern. As the storm intensifies, the inflowing air picks up speed, evaporating more and more moisture from the sea, transferring energy stored in the ocean to the atmosphere. The clouds grow explosively, forming a ring around the future eye of the storm. Then at high altitudes, the flow of air changes direction as the clouds are thrown outward.
The air that goes up in the eye wall, most of it flows out at the bottom of the stratosphere. And as we've said, the air has to flow out easily. That's the exhaust air. That's the waste of the hurricane. Some of the air that goes up in the eye wall actually turns into the eye and sinks in the center of the eye. And as it sinks, the increasing pressure causes it to warm. It's actually warmer than the air in the eye wall that's going up. It's what makes the sinking motion is what makes the eye clear.
Now a fully formed hurricane, the storm draws power from the warm sea below. As the wind picks up, thunderstorms form a tightening spiral. The eye begins to shrink, and the pressure in the eye drops.
The eye wall is one of the strangest features in the atmosphere. It's as different from day-to-day weather as the atmosphere of Jupiter is. Very, very strange conditions. The very fast rotation rate, the very tight gradient of pressure, the low pressure at the surface.
Not yet a mature hurricane, on September 10, 1988, a storm system named Gilbert moves into the eastern Caribbean. On the 11th, it intensifies, becoming a hurricane, and it's headed straight for Jamaica. Late morning on the 12th, Gilbert hits Jamaica head-on. The National Hurricane Center rates the storm a Category 3 on a scale of 1 to 5, with winds over 110 miles an hour.
Here we go to press. We're going to have it over the central part of the island, and it appears now as though it's going to go right down the backbone of the island.
At the Hurricane Center, the storm has drawn a flood of inquiries, along with a crush of local and national media.
I've never seen quite as much activity tonight as there is tonight.
Everyone wants to know the same thing. Where will the storm go next, and will it affect the United States? Forecasters Bob Sheets and Bob Case are at work studying the complex atmospheric puzzle that will answer these questions.
35 nautical miles from the eye. How far have we got our hurricane winds on?
4 times a day, they update the official forecast, beginning with a look at computer predictions.
Every 6 hours by a satellite, or if we have an aircraft in there, every 6 or 3 hours, we get an observation as is shown here on the map. And what we do, we take the position, the initial position at time 0, and 12 and 24-hour positions earlier, and feed it into a computer, and we get the positions back on a copy, and then the tracks are plotted. As you can see, there are differences, and at times there are extreme differences, as much as almost 90 degrees difference, for one track will take off to the east and one will take off north.
These models are each based on different assumptions. One model, based on weather conditions on a larger scale, predicts that Gilbert will move toward a low-pressure zone expected over the southwestern United States, hitting land as far east as New Orleans. A second model, based on past storm tracks and Gilbert's current path, suggests the storm will stay south, held on a westerly course by a high-pressure zone over the southern United States. The Hurricane Center accepts this scenario, calling for Gilbert to continue west toward Texas or Mexico. But these 72-hour forecasts are seldom on target. The average error is over 300 miles.
Now, we have 72-hour positions, but the 48 and 72-hour positions are used mainly for the marine community. Actually, we feel as though, because of the large error involved in the 72-hour forecast, it would probably be better for the general public not to receive this information, because all it does is create anxiety and frightens many people. And if they only realize the large errors involved in that 72-hour position, many times the hurricane's not even going to be there.
It is moving to the west at 17 miles per hour. Winds are now at 115 miles per hour.
Still, Gilbert clearly presents a threat to the Gulf Coast, even if no one knows exactly where.
There is the latest satellite photograph. The eye is very well defined. Of course, once it gets into the Gulf of Mexico, it'll be like a bull in a china shop, and we're going to have to keep a very close watch on that for you.
Bob Sheets tries to hold off any early panic by urging people to sit tight. Do not evacuate until the storm track is more certain.
All along so far, we predicted that it will go into the Gulf of Mexico within about 48 hours. Indeed, at that stage, the people over the Gulf should pay attention.